students to factor, I usually start from the graph, and I can go out on the internet and Google quadratics, and I'm looking for nice rational zeros to the quadratics. When I give this to them, I give them the equation, and then I ask them to identify where those zeros are. And I have them write x is equal to 1 and x is equal to -2. Now the important step there is that I do give them the quadratic to begin with. So then I ask the kids to write x equals -2, x equals 1, and solve the equation by adding 2 to both sides, and I get equal to 0. And that's why I'm calling these zeros. So I have x minus 1 on this one equal to 0, and this is why this is a 0. Now what I ask the students to do is to take x plus 2, x minus 1, and multiply that, still equal to 0, multiply that again, and I get x squared plus 2x minus 1x minus 2, and I can simplify that to x squared plus x minus 2, and this is still going to be equal to 0, but I can match the fact that when I got these zeros, I multiplied them out, I got the same polynomial that I started out with to begin with. So here's another example of a quadratic, and I'm going to ask the kids to identify the zeros. X equals 2. I've given them the polynomial, I've given them the answer, and so we're going to say x is equal to 0. We don't have to go any further with that, and we have x equals 2, so I'm going to subtract 2 from both sides, and so since it's a factor, I'm going to go ahead and multiply them together, and I get x squared minus 2x is equal to 0, and so I'm kind of working the problem backwards, and they can check to make sure they got the quadratic equation that I gave them to begin with. Alright, on this particular problem, I like this graph because both of these happen to be negative, and so when I went through, I got the answer x squared plus 4x plus 3, so I'm going to ask my kids to identify the zeros. Oops, x equals -3 and x equals -1. This time I'm going to add 3 to both sides. This time I'm going to add 1 to both sides. And I just love teaching it this way because I'm able to review so many of the basic concepts that I've already worked with my students. And then when I multiply that, I get x squared plus 4x plus 3. And that's the check with what I had already given them. Okay, this one is a little bit more interesting because I seem to have only one zero, and one of the things that I want to talk through with the kids is we know that there has to be 2 because it's a quadratic. So this would be a great time to say, well, there are 2 zeros to this graph, it's just that they happen to be the same thing. And so it's easy to see that this is going to come out to be x squared, and that gives me an opportunity to talk once again about the parent function for the quadratics. Okay, I've taken this first equation that we had, y equals x squared, and I moved the parabola over to 3. And I'm going to ask my students now to tell me that x equals 3 is a factor and that it has to be doubled because it's a quadratic. When I come over here, I get x minus 3 is equal to 0, x minus 3 is equal to 0. And so then I can have that conversation with my students that x minus 3 squared has a vertex on the x-axis. And then we can go through, and whatever method you use to expand this is fine. This is going to be 6x plus 9 equals 0. This is a really interesting question to do with your students because it really does talk about how the a affects the quadratic. I'm going to ask them to come in here and pick their 0. This is x equals -1. And you'll notice that this one crosses between 1 and 2. So we're going to call this 1 1/2 or 1.5. This gives me the opportunity to talk to students about the fact that this can be written as a fraction 3 over 2. So I'm going to write my two equations, x equals -1, x equals 3 over 2. I'm going to add 1 to this side. And this one's going to take a little bit more solving because I'm going to multiply by 2. And then I'm going to subtract the 3 to make this equal to 0. So now I have 2x minus 3 and x plus 1. When I multiply this out, I get 2x squared plus 2x minus 3x minus 3. And then when I simplify it, I get 2x squared minus x minus 3 equals 0. But if I have the kids graph this and compare the graph on their calculator to this, obviously there's going to be an issue, and that issue is that this is negative. So what I'm going to do is multiply this quadratic by -1. I can multiply this 0 by -1. It doesn't change that factor at all. And then I'm going to come through here and I get -2x squared plus x plus 3. And this starts a conversation about what happens when that first coefficient is positive or when it's negative.